Okay, so in this particular problem, we are supposed to um, find a kid with a or kids with the greatest number of candies, and I guess you've gone through the question already, and it's basically a simple question. So there are n kids with candies, and we are given an integer array called candies, and we are supposed to return a boolean result. So there's our candies, an extra, and given an extra candies over here, and there's our result. So how did we get the result? Okay, so given this extra candies, if you're supposed to add this extra candies to each of the number of candies that a particular kid has, will it exceed the maximum? So the maximum from this input is 5, and so when I add 2 to the extra candies, which is 5, I mean it's greater or equal to 5. So that's why we have a true statement over here. Okay, so you can read this, which says that you return a boolean array result of length n where the result of I is true if after giving the ith kid all the extra candies, they will have the greatest number of candies amongst all the other kids, or false if it's otherwise. Okay, and we are given that multiple kids can have the greatest number of candies. So you can see that we have true over here. It's only this particular kid, but when you check this particular result over here, this particular kid and this particular kid, when we add the extra candies, they are going to exceed the maximum, which is 12. So straightforward. Okay, so I'm going to copy this right here, and I'll move to this point. Okay, so what is the idea here, and how can we get to the solution? Okay, so what we can do is that you realize that the maximum, we can find the maximum. Okay, so we need to pre-compute the maximum so that we don't need to find the maximum every time. And so once we have the maximum over here, the maximum is 5, then we can be able to do iterate through the candies and add the extra candies to it. So this is what I'm talking about. All right, so we only need to know the current maximum candies, and so know the current maximum candy. Then after we know the current maximum candy, we compare it to the potential total. So compare, or let me see, check potential total. Check from the potential total. And what is the potential total? So the potential total, I mean, is given to us from this particular hint here. So I can just pick this particular one and see this is the particular check from. So this is how we do the check: the candies of I plus the extra candies, right? If this particular one is greater than or equal to the pre-computed max, then we return it. We add a true, so we have to store our result somewhere. Okay, for all the available candies. So that's straightforward, and we jump to the solution in Java. Okay, so let me copy this whole solution. Let me bring it here. All right. Okay, so first of all, we need to return a list of boolean, and so that would hold our results. New array list. All right, so that'll be holding our result. And so what is the idea here? So we know that to know the max of the candies, so we have to first of all compute the max. Then after that, the next step will be the steps 2, which is check for, not check from the potential total, but check the potential. So check the potential total. Okay. Okay, so let's compute the total, and so keep track of the maximum candies. So max candies is equal to 0, and we iterate true and candy in the candies. All right, so if we meet a candy, or if this particular candy is greater than the max candies, then the max candies is equal to that particular candy. Okay, so at the end of this iteration, which is of n, our max, we'll be able to get our max candy, and that's our pre-computed maximum. The next step is to check the potential total, and we know from this here that this is our potential total right here. Okay, all right. So let's do that. So we'll use the enhance for loop. Okay, so for in candy in the candies. Okay, all right. So my result dot add. We're going to add a boolean. So if the potential total, which is this particular one, so I'll just copy it here. And in this case, we're not using an I, so I'll just say if the candy, all right, plus the extra candies that we are getting here. So add this greater or equal to the max candies. All right. So if our potential total is greater than the max candies over here, just as we have in our main idea. Okay. So from the pre-computed total, then we'll add a true. If not, automatically it's a false. Then we return our results. All right. So this is pretty straightforward, and we move to our test. And our test, you can see I'm using this particular test case from the um, first example. And so once I run this, I'm setting that, and so I'll just go ahead and run this. All right, so we see one test successful, and so I'm going to copy all this and go here and just paste it here, and yeah, submit the code. Okay, so we have 103 out of 103 test cases passed. Okay, so we can submit a solution for Python 3 as well. And let me do this. Let me copy all this, and let's head to clear this. Let's move to Python 3. Take off the self. Okay, so the same thing, we have our solution in Java. We can look on that, but and just following the same idea, we should know the max. Then after that, we just check with the potential total. Okay, so know the max. So max Candice is equal to 0, and once even if you want to, so for with Python we have the max. I can see max of my Candice, and I'll just get the max. All right, instead of but with Java we don't have that. So this will give me my max Candice. All right, my result will also be a list because you're supposed to return the list. Okay, so for let me just see for candy in so I tell everything. So for candy in Candice. All right, so the result dot append this particular statement. Okay, so the candy plus the extra candies is greater than the max candies. So it's the same condition here. After that, just return the result. Okay, so I have also a test case here with the same test case that we had, and so I'll run the test. All right, so one test pass. So I'm just going to copy all this, head over to solution, just give it a tab, not forgetting the self because it's a class here, and we submit the solution. All right, initial pass, so 103 out of 103 test cases. All right, that's all. Yeah.